This is the review for the exam, problems 16 and 17. So our instructions say to solve the equation. So we want to get everything to one side, so we're going to subtract 7x from both sides, and we get 3x squared minus 7x plus 5 equals 0. This does not factor, so since it doesn't factor, we're going to use the quadratic again. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, when we plug in, the 3 is the a, the negative 7 is the b, and the 5 is the c. And then we're going to plug that into our quadratic, so we get x equals the opposite of a negative 7, which is a positive 7, plus or minus the square root of a negative 7 times a negative 7 is 49, minus 4 times a, which is 3, times c, which is 5, over 2 times a, but a is 3, so 2 times 3 is 6. Now we want to simplify, so we get x equals 7 plus or minus the square root of 49 minus 60 over 6. So that gives us x equals 7 plus or minus the square root of a negative 11 over 6. So x equals 7 plus or minus I square root of 11 over 6. However, because it didn't say to solve this for imaginary numbers, you're going to assume we're working in a real number system. And since this is an imaginary number, then in the real number system, the actual answer would be no solution. So read your instructions carefully, because it will tell you whether it wants you to use the real number system or all numbers. All right, let's look at 17. 17, remember that the 1/2 in front and this 4 are actually exponents, so we're going to move them back to where they belong, which is a 1/2 here and a 4 here. All right, now remember that the product rule tells us that we can write the product of two logarithms as an addition. So if I'm going to take it back to a single logarithm, it's going to become log of b to the 1/2 power, c to the 4th power. But usually they don't want any fractional exponents, so we would rewrite it as log of the square root of b times c to the 4th with parentheses. Notice where the parentheses have to be. If you don't put them in the right place, you get the wrong answer.